customs laboratories. And we provide them with a number of services. A common language for measurements, contributing to standardization, and that's probably our flagship. We develop and distribute reference materials, and we organize inter-laboratory comparisons. I will now focus on the three elements, on the three pillars of the quality infrastructure, and like to start out with the contributions to metrology. Well, we directly contribute to this network formed by the national metrology institutes. And the RMM is the Metrology Institute of the European Commission. And besides these direct contributions, we try to disseminate best practice of measurements by giving training. Well, you know this is, so to speak, the umbrella for the worldwide comparability of measurements, headed by the CIPM and by the BIPM in Paris. And it's the goal of this organization to promote a worldwide uniformity and comparability of measurement results. This has culminated in 1999 in the mutual recognition arrangement, so that each National Measurement Institute acknowledges, accepts, recognizes certificates of analysis issued by another measurement institute. And the overall motto is once measured, accepted everywhere. Totally in line with the motto of the RMM, where we say confidence in measurements. We are a signatory of the MRA and are a full member of the club. So what do? We carry out active research in metrology. We give metrology services to our sister DGs, Directorate Generals, and we transfer knowledge about measurements to interested parties. For example, we are member of, well, associate member, I have to say, of Euromed, but I will explain Euromed in a little while. Measurement capabilities can be claimed. Fair enough. But if claims are not underpinned by a demonstration that you are really able to do the trick, they are worthless. And this is what the BIPM does by the organization of pilot studies and key comparisons in the various subgroups of the CCQM. We had the privilege to coordinate a number of such key comparisons, mainly in the areas of ionizing radiation and in the area of inorganic chemistry. Recently, we started a pilot study on brominated flame retardants as a contribution to the Organic Analysis Working Group of CCQM. And one of the best ways to disseminate the traceability is to develop and issue certified reference materials. And that's in our name. So we are a producer of reference materials, of certified reference materials. We have approximately 650 different reference materials in our portfolio. We distribute more than 20,000 per year on a global level. And just to mention that briefly, last year we released 50 new one sets. We have a searchable reference material catalog, and you are cordially invited to check that out on our website. And this is what we produce. We cater for almost all areas in chemical measurements, be it food, be it the clinical, be it GMOs, and so on and so forth. I give you briefly a few examples of reference materials which have been recently introduced. One, for example, for the measurement of sulfur in gas oil, in diesel. You know, there is European legislation limiting the amount of sulfur in transport fuel simply to reduce emissions to the environment. And member states' laboratories controlling the quality of transport fuel on the national markets need to have a system which allows them to check the trueness, the validity of their results, and therefore we produced in close cooperation with other NMIs a set of reference materials, diesel reference materials certified for the content of sulfur. We are well known in the area of reference materials for GMOs. You know, in the EU, we have a limit of 0.9% of GMOs. If this limit is transgressed, you need to declare the presence of GMOs. For validating measurement methods for the GMOs, you need reference materials. And what we did is we developed matrix reference materials, so to speak, blends of GM and non-GM food. And on top of that, we recently produced a number of calibration materials, which was produced by using plasmid technology. Maya? Okay. CRMs for clinical diagnosis. I mean, this is where everyone, but the public in general, can really feel what does it mean if your physician has a wrong measurement result. He has to take a decision whether to treat your, I do not know, cholesterol level or your triglyceride level, plasma level, by prescribing medication. If he takes the wrong decision based on the wrong measurement result, you are treated, but you don't have the ailment. And we all know that unnecessary treatment is costly, one thing, and there is no medicine without a side effect. So everyone can really feel what does it mean if a decision is taken on a wrong basis. To counter that, European Commission introduced this piece of legislation which should regulate the in vitro diagnostic medical devices by saying that the traceability of values assigned to calibrators has to be assured, and the availability of reference measurement procedures and or materials of higher order has to be ensured. That was taken up by the Joint Committee for Traceability in Laboratory Medicine, a joint undertaking of the BIPM, of the International Federation for Clinical Chemistry, and of ILAC. And the GRC holds or co-chairs one of the working groups there, which tries to bring together all the reference materials producers around the world to canvass what is available and what needs to be developed. We have approximately 40 different enzymes and protein reference materials. On top of that, a number of tumor markers, hormones, and so forth, which can be used for the in vitro diagnostics industry. We realized a couple of years ago that there is a need for cooperation in producing reference materials. And therefore, the European Reference Material Initiative, abbreviated to ERM, was created. The founding partners are the RMM, BAM, Bundesanstalt für Materialforschung in Germany, and the LGC of the UK. But of course, this initiative is open for new members. provided they fulfill very, very strict quality